Hello there and welcome to episode number 2 of LoL Physics, where the math gets a little bit more complicated. Let's go. Alrighty then, we're going to be looking at Ziggs and his Mega Inferno Bomb. We will then ask some questions about it and answer them through the use of physics. Now do keep in mind that the physics here is simple, however I do expect you to have a basic understanding of physics. In addition, I do check my work, however I am human, so if you find any errors, please do comment down below. Moving on to the questions, we're going to ask, what is the initial velocity of Ziggs Mega Inferno Bomb? What is the maximum height the Mega Inferno Bomb travels? And what is the maximum horizontal distance the Mega Inferno Bomb travels? As evident here, we can treat Ziggs Mega Inferno Bomb as a projectile in motion being affected by gravity. Also, we will ignore air resistance. Alright, to answer the first question, which is the initial velocity of the Mega Inferno Bomb, we'll be using the projectile motion equation. In this equation, we have g being the acceleration of gravity, which is negative 9.81 meters per second squared. H initial is anything we can set it at, which we will set at 0 meters. Now, the four unknowns are h final, theta, t, and v initial, which is what we're looking for. However, we can find the final height, theta, and t by doing some research. In order to have a basis of how high the Mega Inferno Bomb is, we're going to find Ziggs' height, which after a little bit of research is 3 feet 8 inches based on this subreddit post. However, according to the League of Legends wiki, the average height of a Yordle is 0.8 meters. So I did the unreasonable thing and averaged out the heights. This led to a height of 0.96 meters or 3.15 feet, so Ziggs is pretty short. As we roll this clip, we're going to freeze it as soon as Ziggs launches his bomb. Using accurate methods, we figure out that this is around 2 times Ziggs' height. That means we result in an H final of 1.92 meters. However, H initial is already 0 meters, which means that as the bomb hits the ground, that will be height final, which is going to be negative 1.92 meters. If we take a closer look at the clip and go frame by frame, we can actually see the angle Ziggs launches the bomb. Now, using the handy dandy protractor tool here, we can actually see that the theta is in fact 30 degrees. Now, I thought originally that he would actually be launching at 45 degrees in order to maximize range. However, maybe he is taking into account air resistance, as this would result in a theta less than 45. Now, going back to our equation, the only thing we do not know at this point is t, which we can actually find by observing the toss again. Once we figure out the amount of time it takes for the bomb to be released and hit the ground, we will have all the variables needed to solve for v initial. As we can see, it takes 3.11 seconds in order for the bomb to hit the ground from initial launch. We now have all of the variables to solve for v initial. Rearranging the top equation, we have a new equation for v initial, and this is just a mere plug and chug, which gives us 29.28 meters per second or 65.50 miles per hour. That means Ziggs is actually tossing this bomb initially with a speed that equal to a car on a highway. Pretty impressive for a Yordle. To figure out how high the bomb actually travels, we can just take the derivative of the equation and set it equal to 0, which will then give us the amount of time needed in order to reach maximum height. Though, as many of you may note, the maximum height can actually be calculated without the actual time needed. All we need is the initial velocity, the angle, and the gravitational acceleration, which results in a 10.93 meter height or 35.86 feet, which is basically 3 to 4 stories tall. Wow, that ball does go up pretty high, or bomb, whatever you want to call it. Now, here's the reason I actually wanted the time, because we can actually see that we are pretty much accurate in terms of when this bomb reaches its maximum height, which was 1.49 seconds, and as we can see on the screen, it's pretty close to it, 1.52, but then again, it's a little bit past the max, but it does seem that our physics do check out okay. And finally, we can use the range equation to solve for how far Ziggs actually throws this bomb, which is 78.90 meters or 86.29 yards, which is actually pretty far considering the fact that he's not even throwing the ball, more so spinning and having the angular velocity actually throw it that far. So pretty impressive. One final question that's going to be pertaining only to the pool party skin is, what is the weight of the balloon, which I'll need to answer some sub questions in order to solve for that. After comparing some ratios with Ziggs' height and the actual balloon itself, I found a diameter of 0.707 and so forth, and then divided that by 2 in order to get the radius. Assuming the balloon is a sphere, then we just use 4/3 pi r cubed to find the volume, which resulted in 0.185326 meters cubed. Knowing that density rho equals mass over volume, we simply rearrange the equation to get mass is equal to rho times volume, and the density of water is 999.97 kilograms per meter cubed, when which multiplied with our volume, it gives us a mass of 185.32 kilograms or 408.56 pounds. That's literally more than 9 times his own weight. There's a recap of Ziggs and his Mega Inferno Bomb. That just about does it for this episode of LoL Physics. Be sure to subscribe so you don't miss any future episodes, and until then, I will see you later.